Advanced Algebra 2, Concept 19, Solving Radical Equations and Inequalities. Now we're going to use all the properties, or a lot of them that you've learned, to actually solve equations and find some values for our unknown. Okay, whoa. So let's back it up here. So here are some steps to go through in your mind when you're solving a radical equation. So look at our examples. Notice a radical equation has a root in it, a radical. In this case, we have a square root and then a cube root that we're going to solve. Also notice we have a variable of x. So the first thing you want to do is to isolate the radical on one side of the equation. So you're going to get rid of everything math that's happening around it. Then to undo that radical, you're going to raise each side of the equation to the power that the radical is, and then you're going to solve the resulting equation. One thing I didn't mention is that you do need to check, because when you're raising things to different powers, you can introduce an extraneous solution. So a solution that looks like it works but actually doesn't. All right, so let's solve 2 times the square root of x plus 1 equals 4. So the first thing we want to do is isolate that radical. So let's start by dividing each side by 2. So we'll get the square root of x plus 1 equals 2. Now we have the radical isolated, so since it's a square root, we can raise both sides to the second power to undo that root. So we get x plus 1 equals 4. Now we'll just subtract 1, so x equals 3. And that's our potential solution. So we need to check. You're going to go back to the original equation and plug in 3 for x. So we get 2 times the square root of 4, and we're seeing if that does equal 4. So the square root of 4, positive square root of 4 is 2. 2 times 2 is 4. So 4 does equal 4. So the left side does equal the right side. That's a true statement. So 3 is a solution. Now the next one, we're going to add the 1 and get the cube root of 2x minus 9 equals 3. Now to undo that radical, we need to raise it to the third power since it's a third root. So we get 2x minus 9 equals 27. Let's add 9 to both sides. So 2x equals 36, and then divide by 2. So x equals 18 potentially. So take it back to the original equation and plug in 18 for x. So we get the cube root of 36 minus 9 minus 1, or actually we can add that one over and equals 3. So the cube root of 27 equals 3, and that's true. The positive cube root of 27 is 3. So 3 does equal 3. So that x equals 18 is a solution. Now let's just continue and work another example. So let's divide both sides by 2. We get the cube root of x minus 3 equals 2. Let's raise both sides to the third power to undo that third root. Notice when you raise a radical expression to a power that what you get is the expression. The expression underneath the radical doesn't change. So add 3 to both sides. So our potential solution is 11. Now let's plug in 11. So we get 2 times the cube root of 8, and we're seeing if that does equal 4. 2 times 2 does equal 4. So 11 is a solution. Now here's a real life problem. So in a hurricane, the mean sustained wind velocity, v in meters per second, can be modeled by this equation. So v of p, that means velocity in terms of pressure, equals 6.3 times the square root of 1013 minus p, where p is the air pressure in millibars at the center of the hurricane. We're going to estimate the air pressure at the center of the hurricane when the mean sustained wind velocity is 54.5 meters per second. So let's grab that formula that we have, v of p, so velocity in terms of pressure equals that expression. So we're going to replace the velocity in terms of pressure expression, so that entire v of p with 54.5. So remember, this is function notation, v of p. That is not v times p. That is just showing you that this is velocity in terms of pressure. So let's start by dividing both sides by 6.3. We're going to round and get 8.7 equals the square root of the expression underneath. Now we've isolated the radical, so we can raise both sides to, in this case, the second power. So 75 and 69/100 equals 1013 minus p. Let's subtract our 1013. And I'm going to round, so negative 937 equals negative p. Divide both sides by negative 1. So our air pressure is 937 millibars. So just another note that when you raise each side of an equation to the same exponent, you could introduce solutions that are not solutions. Those are those extraneous solutions. So we need to always check. So now these problems are going to get a little more complex, but the same basic steps are involved. On our first example, we see that we have the square root isolated. So we're going to go ahead and square both sides. Notice I have to square x plus 1, so that means I take it times itself. So you're going to need to FOIL, and you'll get x squared plus 2x plus 1. Now notice that we have a quadratic to solve, so let's move everything over to one side of the equal sign so that we're in standard form. So we get x squared minus 5x minus 14 equals 0. So lots of options to solve. Let's see if it factors. Two numbers that multiply to give us negative 14 and combine to give us negative 5. So negative 7 and 2. So it will factor as x minus 7 times x plus 2. So our two potential solutions are x equals positive 7 and x equals negative 2. We need to check both of those one at a time. So we'll plug in 7 for x into our original problem, and we get 8 equals the square root of 64, and that is true. 8 does equal positive 8. And then let's plug in negative 2. Oh, I forget to do that, so I come back and do that in a moment. So we'll just leave that hanging. Now the second problem, it's virtually the same thing. We're squaring both sides. On the right, when we FOIL, we get x squared plus 6x plus 9. Now let's move everything over to one side of the equal sign because we have a quadratic to solve. We're going to get it in standard form. And it leaves us with x squared minus 4x, and our 9's just subtract out. This is actually a really good thing because we can factor this just by taking out a greatest common factor of x. Set those both equal to 0, so x equals 0 and x potentially equals positive 4. Now we'll check each of those one at a time. So plugging in 0, we get square root of 9 equals 3, and that's true, and then the square root of 49 does equal 7 when we plug in 4. Now you can see I checked over under our first problem the negative 1, and actually negative 1 does, negative 2. Negative 2 does not work because we end up, when we plug it in, getting negative 1 equaling 1. And so only 7 works with our first problem. Both 0 and 4 are solutions with our second problem. Now with our third, we have both sides under radicals, so we leave the problem as is and go ahead and raise each side to the second power. So we just have a linear equation to solve, so we'll get x's on one side and numbers on the other, and then we'll check our solution, and we get the positive square root of 9 equaling the positive square root of 9, which is 3 equals 3. So that does check, it does work. Let's just continue to solve. Notice these problems are getting a little more complex. So we have two radicals in our first equation, and in that case you're just going to isolate one of them and then go ahead and raise both sides to that, in this case, the second power, because it's a square root. So that means we take the square root of x plus 2 plus 1 times the square root of x plus 2 plus 1, and that equals 3 minus x. Now I'm actually going to FOIL those that multiplication on the left. So my square roots together will simply be x plus 2. Then I'll have 1 square root of x plus 2 times another, or plus another, plus 1. So I just FOILed those out. Now I'm going to combine like terms on my left side. So I get x plus 3 equals 2 square roots of x plus 2. Now I can isolate this second radical expression. So I'm going to subtract my x and my 3 and get 2 square roots of x plus 2 equals negative 2x. Now I'll keep isolating by dividing by 2. So you just, whatever the problem does, you first isolate one radical and then isolate the other. And since we've isolated the second one, now we can raise both sides to the second power. So x plus 2 equals x squared. And then we have a quadratic to solve, so let's put everything over, on this case, the right-hand side, so it's in standard form. I'm going to see if that factors. I believe it does. Negative 2 and negative 1. Yes, so that'll factor as x minus 2 times x. Now I catch that mistake. It should be times x plus 1. And so my actual potential answer should be 2 and negative 1. I'm going to catch it in the check step. So checking 2, I get 3 equals 1, which does not work. Now I'm getting ready to check 1, and I realize I have made a mistake there. So our actual answer we're checking is negative 1. So we get the square root of 1 plus 1 equals the square root of 4. So 2 does equal positive 2. All right, let's work another one like that. So we'll go ahead and square both sides since our first radical is isolated on the right-hand side. So that means I'm going to take square root of x plus 6 minus 2 times itself. So I multiply first terms together, which gives me x plus 6. Outer terms is negative 2x plus 6. Inner is negative 2x plus 6. And then last is positive 4. Now I'm going to work at isolating my second expression by combining like terms on my left-hand side. Now I move everything over that I can. So I'm going to subtract my 10 and my x. And so I get negative 4 times the square root of x plus 6 equals negative 12. Now, one more step to isolate. Divide by negative 4. And now I can square both sides. So these problems just take a little bit. So our potential answer is just x equals 3. So let's go all the way back to the original problem and plug it in for x. So we get the square root of 9 minus 2 equals the square root of 1. 3 minus 2 equals 1. And yes, that's a true statement. All right, now we've got some rational exponents. So we're going to work them in basically the same way. So we're going to isolate our rational expression. And I've just made this decision that I'm going to put this in a part 2 video. So you are done with concept 19, solving radical equations, part 1, and then we will solve rational exponent equations in part 2.